Okay, hello everyone. Now I want to look at the fundamental theorem of calculus part 2. And so what this says is that if f is continuous on the interval from a to b and big F of x is any antiderivative of little f of x, then the integral from a to b of little f of x dx is f of b minus f of a. So big F of b minus big F of a. So you take any antiderivative of little f of x that you want and you just evaluate it at your two endpoints. So we put the bigger endpoint b on top and the little endpoint on the bottom. So here's an example. The integral, so this is the integral from 1 to 3 of x cubed dx. So here a is 1 and b is 3. So if you're looking at this picture, there might be 1 and there might be 3. So we're trying to calculate the integral over that interval there, which we might interpret as the area under the curve from 1 to 3. What this says is that you should just take whatever antiderivative you want, which I'll just take the one x to the 4th over 4. We could have a plus c if we wanted to, but then we're going to take the difference, so that doesn't really matter. So we're going to take x to the 4th divided by 4. That's the antiderivative of x cubed. And then we're going to evaluate at our two bounds. And we usually write this vertical line to remind us that we should be plugging in our two bounds. So what I do here is I do the antiderivative, and then I write down my function twice with parentheses, and then I plug in my two bounds. So 3 and 1. And then I evaluate. So this is 3 to the 4th is 81 over 4 minus 1/4 gives me 80 over 4 or 20. Okay, so I guess what that's telling me is that this area here is 20 square units, is what the interpretation would be there. And so this is also, I should say, is called the evaluation theorem sometimes. This is telling you how to evaluate an integral with definite bounds. Okay, so that's the first example. Now, the next example I want to look at is the integral from -3 to 0 of x cubed. So I guess there we're going, here's -3, there's 0. So we're looking at that area in some sense anyways. So again, I'm going to get x to the 4th over 4, and I want to plug in 0 and -3. So I write down my function twice. And then I plug in the two bounds. So I plug in 0 as the rightmost bound, and -3 is the leftmost bound. And now I evaluate. So the first thing is 0. And the second thing is what? -3 to the 4th is 81, and then there's a minus sign there. So it's minus 81 over 4. And so now this isn't saying that the area is minus 81 over 4. It's just saying that the area is below the x-axis. So that's why we're getting a -81 over 4, is that we're below the x-axis and the area is 81 over 4 there. So that's just one important note about evaluating these definite integrals, is they can give you negative numbers. And that's just telling you that more of the area is below the x-axis than above. Okay, hopefully that was a helpful video. Have a great day.